Welcome to this explainer on day one, AWS Foundations. Look, if you're just getting started with AWS, we are going to set up your journey perfectly today. The goal here is simple. Let's cut right through the noise and grab the absolute essentials you need to navigate and, more importantly, totally secure your very first AWS environment.
Here's our roadmap for this explainer. We'll start with the cloud computing revolution, then break down the AWS Global Infrastructure. After that, we'll hit the shared responsibility model, identity and access management, and wrap it all up by actually securing your AWS account.
All right, part one, the cloud computing revolution. Let's dive right in and see exactly why this tech has completely flipped how modern businesses operate. You know that absolutely dreaded moment when your phone pops up with storage almost full? What do? You just seamlessly push those photos up to Google Drive, right? Or think about firing up Netflix. You're streaming a movie in HD without waiting hours for a massive file to download. Well, that's the cloud in action. You aren't storing those files locally. They're sitting on incredibly powerful computers somewhere far away, and you're just tapping into them over the internet.
To really wrap your head around this shift, think about the difference between buying a car and just calling an Uber. See, in traditional IT, you're buying the car. You're paying high upfront costs for physical servers, you pay the electric bill, the cooling, the manual maintenance, and you pay for all of it even when that server is literally just sitting there doing nothing. Cloud computing, it's like calling an Uber. You just rent powerful computing services on demand, you pay only for exactly what you use while you're actually using it, and somebody else handles all the messy maintenance under the hood. Now, we can actually break down these rented cloud services using a really simple pizza analogy. If you go with infrastructure as a service, or IaaS, like Amazon EC2, it's basically like renting an empty commercial kitchen. You get full control, but you gotta do all the cooking and setup yourself. Then there's platform as a service, or PaaS. That's like showing up to a pizza place where the dough and sauce are prepped, and you just bring your own custom toppings. It's totally perfect for developers who just want to deploy code without worrying about server management. And finally, software as a service, or SaaS, is like ordering a fully baked pizza right to your front door. It's ready-to-use software, think Gmail or Zoom.
Moving on to part two, AWS Global Infrastructure explained. Let's figure out where these rented kitchens and delivered pizzas, our servers and databases, actually physically live out there in the real world. To truly grasp how AWS works, you kind of have to mentally zoom in from a giant global map. So we start with the entire world, then zoom into specific geographical regions, zoom in a bit further into availability zones, until we finally hit the actual brick-and-mortar data centers. So the most crucial takeaway here is that an AWS region is just a specific piece of land on the globe where AWS has clustered its infrastructure. We're talking places like Mumbai, Cape Town, or Northern Virginia. When you launch a server, you are literally choosing which geographic part of the world your data is going to be stored in, and exactly where your application is going to run.
Now, within a single region like Mumbai, you don't just have one giant building. You actually have multiple availability zones, or AZs. These are distinct locations engineered to be incredibly resilient. I mean, they have completely separate power supplies, separate cooling systems, and entirely separate networking. Why does that matter to you? Well, because if a massive storm or disaster hits one AZ and it completely goes down, you can design your app to seamlessly keep running in another AZ just a few miles away. It's a lifesaver. All right, part three, the shared responsibility model. Now that we know exactly where this hardware lives, let's talk about who is actually responsible for keeping the whole shebang safe. This brings us to a really fundamental concept, the shared responsibility model. And it's a very strict dividing line. Basically, AWS is entirely responsible for the security of the cloud. So they manage the physical hardware, the fiber optic cables, the security guards at the data center doors. But you, the customer, you are entirely responsible for the security in the cloud. That means you have to secure your own data, write secure application code, and carefully manage your passwords. AWS is not going to stop you from accidentally leaving your digital front door wide open.
Which leads perfectly into part four, identity and access management. To effectively manage your half of that security responsibility, you absolutely have to master this. It's actually pretty fascinating to visually map out the security boundaries inside AWS. Notice how a principal, which could be a root user or just a standard IAM user, acts as the main entity making a request. Meanwhile, IAM acts like a strict bouncer at a club, standing right between those identities and your valuable AWS resources, constantly checking policies to decide who is actually allowed to do what.
As part of your day-to-day workflow, you're going to create an IAM user for yourself.
The absolutely most important thing to remember about a brand new IAM user is that they start with 0 default permissions. Nothing. They can't launch a server, they can't look at a database, they literally can't do anything until you explicitly attach an IAM policy that authorizes those specific actions. It's called least privilege, and trust me, it is your absolute best friend in cloud security.
And finally, Part 5, Securing Your AWS Account. This brings us right to the absolute mandatory steps you have to take on day 1 to lock down your brand new environment.
So when you first sign up for AWS, you use an email address and a password. Doing that creates your root user. Let me be super clear about this. The root user has terrifyingly absolute, unrestricted power over your entire account and the credit card attached to it. It can delete everything you've built and run up limitless charges in the blink of an eye.
Because of that godlike power, there are some very strict rules. You must never use the root account for daily coding or admin work. That is exactly what your IAM user is for. You absolutely must not generate permanent programmatic access keys for the root user. And honestly, you should never, ever hard-code credential information directly into your application files or share them with anyone unauthorized.
AWS actually makes this threat abundantly clear. You'll see these explicit red warning banners right inside the console, serving as a constant reminder that managing access keys poorly is a massive security risk. I mean, if a bad actor gets their hands on your keys, let's say you accidentally uploaded them to a public GitHub repo, they basically have permanent access to spin up thousands of servers on your dime, and nobody wants that bill.
So, how do we actually protect against a stolen password? Enter multi-factor authentication, or MFA. AWS considers this so critical that they strongly recommend enabling it for the root user literally the second you create the account. It requires a temporary numeric code or a hardware key on top of your standard password. In fact, for the strongest possible protection against sophisticated hackers and phishing attacks, AWS highly recommends using FIDO-based authenticators like modern passkeys or physical security keys.
Armed with these day 1 foundations, you now understand the infrastructure, you know the shared responsibility, and you know the very real stakes of identity management. Your AWS sandbox is waiting for you to build some truly amazing, globally scalable applications. But let me leave you with this final question. Before you write a single line of code, are you going to go secure that root account right now? Because in the cloud, incredible power requires incredibly tight security. Thanks for joining me on this explainer, and happy secure building.